In 5, 4, 3. Hey, it's Coach Wade, Math Age. I've never said it before. And we are back with our live studio audience in Sample Test 10. All right, it is sample test time. Well, the first 10 at least. First part. Okay, so let us discuss all the ways you can apply the first derivative test to this right here. All right? Not that we're doing the first derivative test in calculus. Okay, so number 1. Find the critical numbers. All right. Critical numbers. Number 1 is the only problem on the first half of the test where you do not have to show your work.
DNE.
Yes, you have to show your work.
Answer.
Yeah. The only one where you do not have to.
Take the derivative.
You have to take a derivative. But you don't
Have to do the first derivative
have to do
line.
the first derivative test. Plus 10.
Ouch.
That's a jet.
No, you need
You took
to.
mine the other
That's
day.
plus 10 check right there.
Huh?
That was pretty.
Katie plus 10 jobs.
Anna said it like 20 minutes.
Give her minus 10.
Did it really?
Give us,
I don't think.
she
think
didn't
plus
say
10
it right
is
though.
No, she definitely said first derivative line test.
You got it that fast. Should it be Anna's?
I don't care.
Stephanie?
It's Anna's.
Just jip my last, just jip the
I
plus.
say I
Just
give
give
it.
it to her.
I'll take it.
I'll be a
Yeah,
good
take
sport.
Distribute it out to everyone.
Okay, then you're on the balance beam for your next answer.
Which I won't get.
You
I
might.
said-
Oh, no. It's fine.
The last
I'm going to give it to the right person, so
And I'm
Well, let's
the right person, yeah.
whoever said it first.
The right
I'm gonna do it
person.
right. Okay, let's start this over. 5, 4, 3, 2. Hey, welcome to pre-calculus. All right.
First derivative line.
so-
Damn. Plus 10.
Now, okay. Critical numbers. Critical numbers are where the what?
Derivative equals 0.
Where the derivative equals 0. Now, guess what? It does not have to be a sign change on your number line to be a critical number. That's why you don't need the first derivative test. All you need to do is figure out where the derivative equals 0 and stop right there. Now, everything else on this page, though, is dependent upon sign. Am I sloping up or sloping down or level? Okay? So, for everything else, you have to have a number line. Now, take this derivative. Let's just take the 4 and put it in the front.
Nope.
You can't do that. Instead, we can use the product rule. Nice. Ho d high. So ho d high is 3 plus high. Ooh, let's see, d ho. 2x minus 1 to the 4th. 4. Base stays the same. And new power is 3. Chain rule, the most important part is times 2. Okay? Make sure you have that for your chain. Now, let's factor out the what? Greatest common factor. Take out as much as you can.
3.
How about a 3? Slice and dice.
2x minus 1
2x minus 1 to the third. Slice and dice. Okay. Now we go on one of our favorite games.
Easter egg.
Easter egg hunt. You remember? Good. There's one Easter egg right here. 2x minus 1. Plus sign carries. Ooh, a lot of Easter eggs hidden over here. Don't forget that X is in there next to the 3 you got crossed out. So that makes what? dx. All right. Now it's time for one of our old favorite games called Mr. Wade's Farm. And old Mr. Wade had a farm. E-I-E-I-O. And on that farm, Mr. Wade had 2 pigs, and -1 cat, and 8 pigs. Now what kind of farm is that? How about we have 10 pigs and -1 cats? Now that's a normal farm right there. Okay? But put your like terms together. Nobody says I have 2 pigs and 8 pigs. Okay? And I've seen people leave it like that and they get lost and they can't figure out how to solve the problem because they didn't combine. All right? So I have 10 pigs and -1 cats. All right? And since I'm looking for the critical numbers, let's set that equal to 0. And when does 3 equal 0? 3 equals 0, that's preposterous. And when does 2x minus 1 equal 0? Okay, that'd be 1/2. And you don't have to worry about the cube because 0 cubed is 0, so just worry about the inside. And when does 10x minus 1 equal 0? 1/10. I wonder if these are sign changers or not.
Yes.
I think they probably are. Actually, both of them are. Now, for critical numbers, will it matter?
No.
Doesn't even matter. You're done. Okay? Answers. So you're just trying to find the neutrals, or should we say there was another word we use in this chapter, other than neutrals. Find the whats? The zeros or the roots? Roots? Yeah, roots, yeah. Find the roots of the first derivatives, which I do. All right, that's all you have to do. Done. Okay, now it's time for the absolute minimum. How low can you go? Okay, so I have this graph, and I want to know the absolute minimum. What is the one key word in that entire sentence that tells me derivative world? It is the word minimum. There are 4 words I want you to look for in pre-calculus and calculus. Minimum, maximum, and I guess critical as well, but more importantly, increasing, decreasing. If you see any of these 4 words anywhere in math, I would take a derivative right away. Okay? All right. Now here's what we have to take a derivative here. An absolute minimum is a what? It's a valid. Matter of fact, it's the lowest place, isn't it? Yeah. That's got to be a changer, right? So I'm looking for the absolute lowest place. Why would I need a derivative to tell me the lowest place? Because at a valley, what's so special about the tangent line in the valley? 0. So that's why we're looking for slope 0. We did that the very first day, right? So don't forget why we're doing this. So take a derivative, 4x cubed, find where it's 0, and that would be at x equals 0. Gotta have it at 0. Well, wait a second, there's one problem. Maybe that's not a valley. Tangent lines are level at valleys. The roller coaster is also level at peaks. So you can't just trust it until you verify that a number line.
We just got a minus.
I'm about to label it, all right? That's very important to label that graph, okay? So, y prime, here's my critical number, 0. Let's pick numbers around 0, such as negative 100, like that, and 2010. All right. Take that, plug it in, let's see what happens. Now, remember on the test, don't put them in the wrong place or you'll miss everything on the entire test, all right? Put them in the correct place. If you are doing what is called a first derivative test, you must test them in the first derivative, because it is, after all, a first derivative test. Don't go back here, okay? So, negative 100 cubed is?
Negative.
Yep. Big old number with a negative, right? Times 4 is negative. 2010 cubed is big old positive times 4 is positive. Okay? Do we have a basin or do we have a peak? It is a basin. A valley can always be indicated by
A negative and a positive.
negative. Positive means the original function was
Probably.
decreasing, something decreasing, decreasing, and then increasing. The slopes are going down the hill, the slopes are going up the hill. Okay? Now just do like a jagged sketch here so to make sure you know what's going on. Okay? Don't have to make it curvy. In real life it's curvy because x to the 4th is a parabola that's been shifted
Up 3.
Down.
down 3. Because on the outside is normal, inside is backwards. So it's down 3. Wow, I'm so surprised that I got it down up. Okay, no, I'm not. All right, so it's a big old bracket. So we were looking for the what, absolute minimum? There it is. Okay, well, I'll just circle it. Okay, tell me what it is. All right, yes, the valley is a coordinate 0, something. And you must go to the original equation. The only thing we ever use the original equation for in math is to find y coordinates, if you haven't noticed. That's it. So you take the 0, you put it back in there, you get 0 to the 4th minus 3. Oh yeah, the vertex is the bottom, and we went down 3. That makes sense. You almost can do that without a test. Okay? But it's a good practice to see how you test the lines. All right, that's number 2. Now, number 3, find only the x coordinates. So I'll give you a little time saver here. You don't have to plug it back in. Just give me the x coordinates of the relative maximum. Okay? Derivative, key word. Maximum. Plural of? Maximum. All right. So don't just find any old peak. Relative maxima are all the peaks, right? Every single one of the peaks. All right, so the derivative would be as follows. 16, x to the first minus 4 to the third. Okay, anything you can take out of that? 4x, all right, oh, this is handcrafted by Mr. Wade. 4, sure it is. 4 minus x squared, difference of two squares, handcrafted. Okay? And a little button over here. All right, so you're going to get 3 solutions when you set this equal to 0. And find the roots. X equals 0 plus or minus 2. If you want, now this is optional, if you want to factor difference of two squares, wouldn't it be 2 minus x, 2 plus x? Okay. If you want to do that, you can. If you just can cut to the chase, that's even better. Okay, now, number 9. Who is the smallest? Negative 2 is the smallest. 0 is in the middle. 2 is the biggest. All right? Well, let's see here. Let's put in some sample points, such as, okay, how about, yeah, it's kind of a tight squeeze here. There are infinite numbers between negative 2 and 0, right? But there's only one integer. So probably negative 1 and 1 if you want to steer away from fractions. And negative 1,000, nice. And 100, right? Okay. Now remember what I like to do. If you want to do this by orange number and just say negative 1,000 plug, you can do that. I prefer to do this by group up here. Okay, if you like that better, you can do it that way. Just look at the 4x for a second. 4 times negative 1,000 is negative. 4 times negative 1 is negative. 4 times positive 1 is positive. And 4 times 100 is